Hello, everyone. Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I'm joined by my co-host,
Ben Wilson.
And today we are going to be talking about a really interesting topic. Once again, all of our topics are interesting. And this is essentially how to edit and contribute to an existing code base. So chances are that if you work in an industry where you write code, there are existing code bases, and you have to A, efficiently understand them, and B, figure out how to contribute to them, and C, make sure that your contributions are within style and easy to maintain. So today we're going to be talking about some best practices for how to do that, and once again leveraging Ben's amazing wisdom on the topic. So yeah, let's dive in.
Hey folks, this is Charles Maxwood. I've been talking to a whole bunch of people that want to update their resume and find a better job. And I figure, well, why not just share my resume? So if you go to topenddevs.com/resume, you enter your name and email address, then you'll get a copy of the resume that I use, that I've used through freelancing, through most of my career, as I've kind of refined it and tweaked it to get me the jobs that I want. Like I said, topenddevs.com/resume will get you that. And you can just kind of use the formatting. It comes in Word and Pages formats, and you can just fill it in from there.
So we're going to set this up with a project. Let's say you are a software engineer, ML engineer, whatever you want to call yourself, and you have 1 month to take a pre-existing code base and improve it. Now, this pre-existing code base is a very important forecasting model. And what it does is it predicts the number of Santa Clauses that will be at malls throughout the United States. And this is actually a real thing. When I was traveling through Colombia, I met a guy that actually books Santa Clauses. He like did telemarketing or like remote working. And he was the person that you would call when you need a Santa Claus for your mall. And so it's a real industry, I promise. Or he could have been lying, who knows? And as the holidays roll around, things get weird, as you'd expect. And your organization says, whoa, these models are not performing as expected. So we would like you to go in and fix these issues, figure out what's going on, specifically look at some hyperparameter tuning, and edit this existing code base to make it a lot more efficient. So, Ben, does that sound like a reasonable setup to you?
Yeah, let's say that the existing code base was done with best intentions and maybe done by an intern data scientist who hard-coded hyperparameters to a model. And it was working great for the first 10 months of the year. And then now holidays are rolling around and people are like, hang on a second. These results don't really match with the data that we're collecting. So can you fix it?
Got it. Cool. So, Ben, you are tasked with this. What is the first thing that you would do?
The first thing from a project perspective is to look at the actual results. And that would be check the predictions that people have problems with and then the actual data. So just do an analysis. And I would usually communicate something like that. That activity is like, hey, this is the pre-work research that we need to get done. And it's probably going to take 2 days to go through and fully understand what's going on. Maybe it's, hey, we might have additional data that we collect that we could have in advance that would help make the predictions better. Or it could be that the model just drifted because there's some latent effect that we don't collect, but the tuning is not allowing for generalization to the point where that wouldn't be a massive influence to the model. So once I get that game plan down, and I'll write up a report generally just for myself and maybe a couple other people on the team that's very ML focused. It's not written in a business sense because it's not something that you're going to be sharing with the business because they're not going to care about those technical details. But it could just be a bulleted list of like, hey, here's some issues that I'm seeing on just the predictions versus the actual data and the featured data that is coming into this model, just so that I have an understanding of what the problem space is. And the important thing with this is before looking at the code base, because I don't want to look at the code base and any potential comments that are in there or structure of how this thing was built that would bias my own analysis that I'd be doing. If I read through the code base and see that, oh, they're doing all these feature engineering work and all this transformations and stuff in order to create all of this additional data that's going to be going into the model, that's going to sway my own understanding of the problem and it'll make me focus on those aspects of like, oh, maybe we don't have this data. That's why they had to create all these features and do this feature engineering work to generate new data that doesn't actually exist in its raw form. So I like to go in blind to understand a problem. But once I get that list of things that I know I need to look at or an analysis, let's say the result of this is, oh, the model's just not tuned properly. And it's the features have drifted a bit, but there's nothing pointing to, hey, there's this uncaptured data point that we're not able to put into the model that would help make it better. So if I get to a point like that, I'll know like, all right, we just need to retune this thing.
Got it. Cool. So we treat the code base essentially as a black box, potentially take a look at the inputs, which would be the incoming data, really take a look at the outputs, and then figure out where things are potentially not as expected. Then from there, we actually are going to be diving into the code base. So this is something that I struggle with here and there, especially with unfamiliar code bases, which is there's, let's say, 500,000 lines of code. Let's call it Python code. How do you Okay, let's call it 50,000 then for fun.
Yeah, that's about right for a somewhat complex project code base.
Cool. So 50,000 lines of Python code. Let's say it's reasonably well written. You can actually read the lines, but going through and reading every single line, then working backwards to understand the structure, that's just not in your ability because it would take so much time. I mean, you could do it, but let's say that would take 2 or 3 weeks full time, and you want to be more efficient. So Ben, when you're looking at a code base, where do you start when you're trying to understand the structure of that code base?
So I would counter that statement with, it's not that I don't have enough time to look through a code base like that. I'm way too lazy to do that. That's just way too much work. And it's work that I know is not really going to be worth my time. And I just don't care. There's ways that I'll do throughout development of creating modifications to a code base where I'll get to seeing if there's dead code present or there's inefficient ways that code has been structured and written, and maybe look at potentials for refactoring that need to get done for maintainability. What you don't want to do is read through the whole code base and with sort of an open mind of, oh, I'm going to try to find everything that's wrong with this code so that I can make a list of all the changes that I need to make. At that point, sometimes it's more efficient to just rewrite from scratch. If you're starting to find a lot of issues in the code of like, well, I wouldn't write it this way. It's irrelevant for project work. You're tasked with implementing a feature or with fixing this project that's falling apart. If I want to understand how this thing works, the first thing that I'm going to do, and I do this with any code base that I'm looking at, is I go to the tests. And the first thing that I'm looking at is, do tests exist? If they don't, that's a pretty big red flag for me. And that lets me know that maybe this wasn't written by somebody who has experience in software development, and maybe they're unaware of how important that is. So that lets me know that, hey, the code's probably not written in a testable manner because there's no tests in existence. Or if I look and see the test, it's just one test and it's one massive integration test that's like, hey, run the main pipeline from start to finish and check to make sure that our predictions are within a range between these values, then at least they were well-intentioned to create that validation of saying, like, does this produce data that's usable, yes or no? But it lets me know that the code is probably going to need anything that I'm going to be interacting with and touching is going to need some amount of modification. Doesn't need a total rewrite, hopefully, but it might need chunking functionality up so that I can write tests, at least start with writing unit tests to validate the code that I know I'm going to have to be adding to this. So on the other hand, if I go in and I see a full test suite that's been written, that's like, hey, there's modularized code here. There's tests to validate different functions or different methods within classes. And there's pretty good test coverage for the main functionality. In that case, I'll drive to sort of the higher level unit test, the things that are testing what we would call like the public APIs or your main method. And I would look to see where does that exist, and then look at the actual usage pattern of that API. Like, oh, well, where in the code is this is my main entry point. Because if we're talking about a code base that has 50,000 lines of code, hopefully that's not just in 3 or 4 files. It's probably going to be in 100 files or 200 files or 500 files or something. So there's probably a lot of modules in that code base. And instead of wasting time like hunting around through the code and opening up directories and trying to find like, hey, is there some logical design here? It's just easier to go to the test suite and say, oh, here's the test that tests like the fit of the model. Can it fit on a mocked up data set? And then I'll go and look and be like, okay, they have a mock data set defined here. We're talking about time series here. So maybe it's, sample data or synthetic data that's been generated. Well, with that synthetic data set that represents accessing the raw data, where does it go? What's the process of operation? And then I'll start just using IDE tools to say like, hey, find this implementation and look at the code there and then walk backwards. So I always start at that. Like, where would the user be using this, or where would the computer that's running the scheduled job or triggered job, where does it go and what does it do in order? And there's going to be a point where you're going to start hitting stuff like, for a well-designed repository, you're going to start seeing calls to utility modules and calls to helper functions. And I don't look at that stuff because it's really irrelevant. You kind of hope that all that stuff is built correctly. If it doesn't, then this project wouldn't even be executing correctly. It would just throw exceptions or wouldn't be able to access data, or wouldn't be able to change a type or whatever those utilities typically are. So only look at those if need be, since we are on a time crunch. And then once I get a full understanding of where the processing happens of data ingest and then gets applied to this pipeline, and then, okay, here's where the model gets fit, then try to find, knowing that this project that we're talking about has hard-coded hyperparameters, that's probably in the method that's wrapped around the model fit. So I would look to see, how are those defined? Are they constants that are defined in a separate file? Are they, worst case scenario, are they just strings embedded in the code itself? And then I know, okay, I'm going to write a note to myself like, hey, break this out into constants, try to find other constants that need to be defined externally. Or it could be that they're using environment variables and these are just read with a default that's applied. So the reason that you go through and do that analysis before you start implementing anything, before you start writing any code, you want to see if there's functionality pre-existing that's just not being used. Like maybe the person who wrote the code wrote some means of doing hyperparameter adjustments to this code base, and in prod, they're just not using that. So that would shift the development focus of implementing this feature to something far simpler. It's like, hey, this already exists. Somebody already built it. We're just not using it. Let's just use it. Or it could be that, hey, it's string encoded hard values within the code, almost like script. And in that case, I know, okay, we need to implement hyperparameter tuning, an automated hyperparameter tuning. So what is that going to look like? And where would that live? And start blocking out mentally and writing notes as well of like, hey, this is what I'm seeing. This is the general design, to give me a sort of a game plan of, okay, here's the things that I need to implement here. And here's where they would live.
Got it. Sort of a tangent. How many layers of abstraction do you usually think is good?
Depends on what you're doing. So if you're doing applied ML, and for this use case, we're doing like time series forecasting, and if you have an abstract base class that is defined with like, hey, here's all the method signatures that we want, and all of them just basically say pass within them. And then we have our model that's created in a class that, inherits from abstract base class, and everything looks really pretty. It's very well documented. And then you see that there's no other implementation off of that ABC, that abstract base class. Then I know that somebody's maybe was trying to show off, but then nobody cares, right? So usually like very junior people will do stuff like that as sort of like, hey, I need to show everybody that I understand how object-oriented programming works. And they'll overbuild or over-engineer something, thinking that that's required because they've seen that in other places. They're like, well, I went to this open source repository and I saw that they use abstract base classes and they use these like abstract methods, and then they're overriding, the functionality of that within, an inherited class. And yeah, those open source packages are doing that because they need to do that, because off of that abstract base class, there's 15 different implementations that all need to have the same signature in order to make another layer of abstraction on top of that for control flow. It's to simplify the code. And so that code base isn't copying and pasting the same structure over and over and over and over again, because that's unmaintainable. So if I see stuff like that, I know, like, hey, I don't need to delete all this stuff. I don't need to go in and with a wrecking ball and rewrite all of this code. It's not hurting anything. So I just need to apply a scalpel and be like, hey, instead of rewriting all this, because it runs, it's just this one feature is missing, I'll go through and adapt. And it might be like, hey, my method that I need to add in this class implementation, it also needs to live in the ABC as well. So I'll carry on with the existing design and apply that into that ABC. And then in the inherited class, I'll write my logic that I need and try not to rock the boat too much, because there's nothing to be gained by refactoring all of that out. That might be future work. It might be like, hey, next quarter, we have free time to make this code base a little bit more maintainable. So let's plan out some refactoring work. But generally speaking, you're not really going to be doing that. If it's not broke, there's no point in really doing that.
Yeah, if it ain't broke, don't fix it.
Yeah.
That makes sense. So one more question on this, which is, how do you know when you know enough to start writing code?
If I can look at the code base and know exactly how to do a prototype, like a really rapid test, where I'll take the existing code base, I'll package it up, I'll put it in an execution environment that I have like interactive control over. So we're talking about time series forecasting in Python. So I'll build a wheel of the existing code base, hopefully setup.py is done correctly and build tools work. But I'll get it to a point where I can build an artifact, and then I'll import that artifact in an interactive environment. And that gives me access to all of the public and private methods and classes and everything within that code base. At that point, I'll start getting the output right before my code would need to live. So that would be whatever the state of the system is right before the model is fit. And I'll use the existing code base through import statements to give me that. And I'll just look in the code and say like, hey, coming into fit, or this fit abstraction that's written, what are those arguments? Where do they live? Is it an initialization value from the modeling class? If so, I can just step through the code and get to that point and then assign a variable locally in a Jupyter notebook or something. Or if I'm doing this on Databricks, I'll do that there. And then I write my logic. And my logic doesn't have to be anything approaching what the final code is going to be. And in most cases, I don't even do that. I don't know. Like I said before, I'm kind of lazy. So if I'm just trying to prove something out, I'll write script. I'll do some nasty, funky, janky code that's just I know it's the things that I need to get done. And I need to make sure that this is going to potentially solve the problem. So what is the problem that we're faced with? The model's not tuned. It's not performing very well. Can I take the input to the model fit process, run it through an automated hyperparameter tuning framework? Then the output of that, can I pass that into the fit method and run the rest of the code that's in existence in the code base? And all of a sudden we get better results. If that's the case, I can test that out in a couple of hours by doing some crappy little scripting. And if I know that solves the problem and like, hey, we're getting results now that work, and I test that, I never trust myself. I've learned that over time. So I'll do a bunch of different iterations. Maybe I'll change the data set, modify that in some way, try to say like, hey, if I cut off the last 2 weeks of data and then run this through my script, does it still work? And if it does, and I feel fairly confident, I'll output the results of what I was using for analysis, and I'll share it within the team, try to get at least one or two people to say like, yeah, that's pretty good. That's sweet. Yeah, I think that'll work. And at that point, it's time to talk to the business, whoever asked us to fix this because it wasn't working. Spend a little bit of time, maybe, 2 hours or so, and create a nice presentation that it can send asynchronously to those people and ask that they review it in the next 24 hours. And within that messaging, I'm not talking about what we did, how we fixed this, or how much time it took to do it, because they don't care. Like they just want it to work. So I think about the messaging that if I was in their position, what would I want to hear and what would I want to see? So I would want to see current existing output. Like, hey, the model was trained on this data and here's the predictions. And this is what's in prod right now that you don't like. We did this thing, or maybe you do 2 or 3 different things if you can rapidly iterate, and then just show them and say, which do you like best? And it's important to present that in a way where you're not talking about implementation, or even in abstract terms of talking about like, hey, we did this really cool thing and it's super advanced, and here's this one. And then we did this really simple thing. And if you start talking about things like that, depending on the person, you may get bias from them. Some people don't like complexity. Some people don't like simplicity. Some people want to use cutting edge techniques. Some people don't ever want to use cutting edge techniques. So if you explain implementation details to people that shouldn't have to worry about that, their answer may be biased by their own personal understanding of risk, or like what they like. Some people just like new stuff. Some people don't like new stuff. So when presenting data like that, I would just say, here's option A, here's option B, here's option C, and then here's existing. Choose the one that you like the best, and then choose the one that you like the worst. Tell me just honestly, how bad am I at my job, based on these results. And personally, I don't care. I used to, when I was, more junior, I would want to build the cooler thing. I'd be like, hey, I really want to implement this super fancy way of doing this. And I think it's pretty stable and it seems really slick. It's using this really cool new project that it's in the open source. And that's going to make me feel like I've accomplished something if I implement this, because it's harder than the other ones. Now I don't care, like, at all. There's no emotional investment for me in implementation, whether it's simple or complex. That ship has long sailed. I just want to make sure that it's like the problem gets solved so that I don't have to hear about it again, and we can move on to other things and get more things done. But the primary motivation is making sure that that person who brought the complaint to us is super happy with the end result, regardless of how it gets fixed.
Right. And you still really enjoy your job, right? You still find cool things.
Yeah. I mean, that's no longer the motivation, though. It's not. That used to be the motivation of like, oh, I want to use this new framework. I want to use this, learn this new thing. The longer you do stuff, you realize that the more senior you get, the more you have to just do that constantly. Maybe it gets boring over time of like getting excited about learning something new, because it's just something that's so common if you're working in development and building projects and stuff, you're always learning new stuff. So it doesn't have that excitement factor that it does when you're sort of just getting into this job or this profession, where everything's new and you haven't had to really train yourself to learn really quickly new things that are completely new concepts and actually build things with them. So I think that's why some people really get out of the profession of software development or ML engineering or data science. The people that were doing it for that excitement of learning new things and feeling like they're building something amazing that people are going to be very impressed with. If that's the motivation that people have, and they stay with that motivation for years, they end up getting disillusioned and sort of disgruntled, and they end up quitting the industry and doing something else. The people that shift their focus from that excitement into, hey, I just want to solve problems, or I really like being invaluable to other members of my team by helping them and them helping me solve problems. That mentality is something that has duration.
Hey there, this is Charles Max Wood. I'm excited because I wanted to let you know about this thing that I pulled together that I've been dying to have this for years, and I never felt like I could. And then I just realized that there's no reason why I can't. So I'm putting together a book club, and we're going to read development-focused books, career books, technical books, whatever. The first book that we're going to do is going to be Clean Architecture by Uncle Bob Martin. If you're not familiar with Clean Code or some of the other stuff that Bob has done, check that out. I've also talked to him on the Clean Coders podcast, which is on Top End Devs. But yeah, we're going to get on. He's going to show up to some of our meetings. And what I'm thinking is we'll probably have like 5 or 6 people part of the conversation along with Bob and I at the same time. And we'll just, so somebody can come on, they can ask their question, and we'll just rotate people through. So we'll mute one person, unmute another person when it's their turn to come on and be part of the discussion. So we'll do that for like an hour, hour and a half. And then the other part of it that I'm putting together is just kind of a meet and greet gather area on GatherTown. And so after the meetup and the call, what we'll do is we'll all go over to GatherTown, and you can just log in, walk up to a group and have a conversation. And that way we can all kind of get to know each other and make friends and get to know people across the world. One thing that I'm finding is that, yeah, the meetups are starting to come back, but a lot of people don't have the opportunity to go to a meetup. And I really want to meet you guys and talk to you. So we're going to put all that together. It'll all be part of that book club. You can go to topenddevs.com/book club to be part of it. And I'm looking forward to seeing you there. The first book club meeting will be in December, the beginning of December. We're starting the first week of December. And you'll also be part of the conversation about which book we do next. I have one in mind, but I want to see where everybody's at. So there you go.
Yeah, that's a really interesting shift from being self-focused to team-focused and impact-focused. Yeah, that's really cool.
Yeah.
Okay. So we've touched upon this topic a couple of times, but getting into the nitty-gritty, how would you estimate the amount of work that's required to create a feature? So let's put a face to the name. We are forecasting Santa Claus demand in malls throughout the US. And again, there was some drift, whether it be concept, feature, you name it. And our original hyperparameters aren't doing that well. So we're looking to implement an automated tuning framework. Yeah. So you overall have understood the code. You've created a wheel in a dynamic environment and played around with it. So you understand what's going on. How would you iterate through all of the potential features that you could build to solve the problem and sort of scope how much each work or each feature would take?
So that's a question would probably be impossible to answer for anybody who hasn't been doing this work for a long enough time. The only way to answer that is experience. Like how long did somebody tell you it was going to take 8 years ago when you were working on a similar problem? And how long did it actually take you? And the other 17 times that you've implemented this similar functionality within code bases that kind of look like the one that you're looking at now, how long did it take you? And keeping kind of like a mental history mapping of project type and like code base quality, you can sort of intuitively guess, plus or minus a couple of days of work, how long it's going to take you to do it. And that's for somebody who's pretty senior, who's been doing this for, a decade plus. Now, the important thing in work estimation is knowing that you do need some amount of buffer time because unexpected things can happen. You might find that, oh, geez, in order to make this hyperparameter tuning work, we need to record the results somewhere. So now we need to integrate with the tracking tool. We need to get like MLflow as part of this. And, we need to use like a custom model in that because maybe this particular framework that we're using for doing the forecasting isn't supported. So there might be some additional work that needs to happen there, or we need to get a little creative with implementation around that. But aside from the buffer time, knowing that the estimation that somebody might give who's pretty senior is highly specific to themselves or people of similar seniorities. And if you don't know how to estimate for other people, talk to a team lead. If you're a very senior IC, or a lot of times the people that are doing the work scoping are the team leads or extremely senior ICs that have been team leads in the past, and they understand the capabilities of people at varying levels of their career and backgrounds. So identifying who's going to be doing the work and then estimating a baseline implementation complexity for an extremely senior person, and then understanding what that translation would be for people that maybe aren't as skilled is super important, because you don't want to stress out somebody who's pretty new. You also don't want to annoy the business who's asking for this change. So it's a balancing act of, is this so important and critical that this absolutely just needs to get done now? So maybe 2 senior ICs are going to work on this. They're going to get it done in 2 days. And it's going to be like ready to ship within the next 72 to 96 hours. Or is this something that you can identify as a growth project for somebody who's more junior, and the business can wait a couple of weeks to get this out there, and pair up a senior IC with a junior person? So the senior IC is the rubber duck for the junior person, and they're there to mentor them and be a resource for them so that you can build the next generation of senior ICs. Yeah, work estimation. But I think your question was, how do I do it personally? Or like looking at something, and I go off of prior knowledge of how long it took me to do something similar in the past, and then look at the code base and start piecing together. I don't know. I'm a visual person, so I'll visualize in my head what the edits would be within an IDE. Like, all right, I know that in this package, I'm probably going to be adding, these 4 methods, and then this other package, I'm going to be adding these 3. So I know that I need to write unit tests for, at least 7 unit tests to test these new added methods. And then I'm probably going to want to create a couple of utility functions for some of this common functionality that's going to exist within some of these methods. So I'm going to need to test that as well. And then in order to get it to fit into this fit portion, I'm going to need to write a partial function modification to that fit so that I can use it to like reuse the fit method over and over and over again. And then I need logging and I need instrumentation around this. So in order to track the history of this and be able to see, is this selecting the one that I want? Is it the most generalizable? I would just start thinking about how long would it take me to write all that, and then test it, to write the test for it. And then how long would it take for me to validate that these tests work? If there's no tests in existence in that code base and I have to be the one to create the first couple of them, I know that I have additional work to do. I have to set up PyTest, and I have to make sure that I can execute that from the command line properly. I need to create requirements within this code base that now installs the correct versions, the pinned versions of PyTest and all of the supporting libraries that I need to do this testing. So I'll get a feel in my head of, okay, how long do I think this is going to take? And then whatever number I come up with, I always multiply it times 50%. So
I was about to say
times 1.5 times that estimate. That's what I tell other people how long it'll take, because I'm really bad at estimating that. I know I'm really bad at that. And I know that every time that I've given myself that extra buffer room, I haven't had as many problems with getting something into production. But when I throw out that first number, I always have problems every time. So
it's an interesting phenomenon. When you throw out an initial number of, let's say, 2 weeks, and you think you can do it in 1 week, people are like, it's a bit longer than I expected, but great. But where people get really mad is when you keep saying, I just need an extra couple days, I need an extra week, and it keeps going beyond their expectations. So bite the bullet, overestimate, and then you'll be able to get it done in time, or maybe even early, and then you can go read a book or do whatever you do.
And where it gets really dangerous is if you're working at a company that has a release train schedule where production deployments are handled by an internal DevOps team. And if your code isn't ready for shipping as of this release date, it's not going to get released. It's going to go to the next release, which could be 2 weeks, 3 weeks, 6 weeks later. So it's important to communicate upfront with that buffer, being very confident that you're going to have everything figured out, everything's going to be done, and negotiate with people who are in management of like, hey, this is how much time I think I'm going to need. It's going to put us at this timeline scale. And if it's past that release date, the manager, director, whoever could say, no, that's unacceptable. Like, we need to get this fixed before that time. And if that's the response that I get, then I start thinking about feature pruning. What can we get away with trimming off of this in order to hit the deadline that we have? And if it comes down to, hey, we don't have time for hyperparameter optimization, we can do that on the next release. But for this release, we need to get something out there that's just better than the garbage that's being produced every day by the production deployment. And if that's the case, then I'm, usually I think about that before I start doing the estimation of the project. I'm like, hey, what's our timeline here? And if they say, hey, you got 2 weeks to get this out, then I'm not thinking about hyperparameter optimization. I'm not thinking like, oh, I'm going to write a wrapper around Optuna. I'm going to get this all working. I'm thinking more like, I just need to retrain this thing and get it in a better state than it is right now. So I'll definitely use something like HyperOpt or Optuna or one of the many frameworks out there for optimizing, but I'll just take the output of that and replace it in the code for that release. Be like, okay, we're in a better spot now.
Got it. Yeah. And then one more point, sort of an alternative angle to having a ton of experience. And this is something that I personally rely on a lot. And that's essentially when you're creating a project and you haven't built something very similar in the past, and you don't know necessarily how long it'll take for you to A, learn the stuff, and then B, implement it correctly, and then C, have reviews and iterate upon that. It's really, really valuable to create very small prototypes of each component. It at least gives you the initial framework and structure for how those things will be built in the production environment. And then from there, usually scaling it out to make it work is a lot easier because you know, all right, these are the 3 building blocks or the 3 structures that I'm using. And then from there, it's a lot easier to move. If you're trying to do it all in one pass, that's what the super senior software engineers are for. That's why they're paid twice as much as you. They can do it all in one pass. But often when you're in a more junior position, iterating is very effective and important.
Yeah, I mean, I couldn't agree more. And even though some people are senior, there's times when you have to do stuff like that as well. You have to do a prototype. It's all about the size and the complexity of what you're trying to build. So there's stuff that I work on now that, I don't need to build a prototype for, even though it might be, 300 or 400 lines of code that's being added to a code base, or I know that I need to implement this feature that I may have done before. I'm not going to do prototypes for stuff like that if I'm very familiar with the concept of what needs to get built and how it needs to get built. But if it's like, hey, we have this new feature that we need to implement it's nothing that I've ever worked on before. In order to grok the concept and figure out what the gotchas are, I absolutely have to go onto the internet, do a bunch of searching, read some stuff, see if there's examples out there. If it's interfacing with new packages that I've never played with before, I got to read their docs. I got to look at their getting started examples. I'll look through their code if it's open source and try to really understand what it is that I'm getting into before I estimate, like, okay, I think I know what I'm going to do now. And then I'll go write some prototype code and be like, do I really understand this? And if I try this in these different ways, where does this break? So that I can write notes to myself and be like, hey, in implementation, these are the things that I need to think about. But even the most senior people that, I currently work around, none of that is done in isolation. Before you actually start writing an implementation, it's all peer reviewed. Like your plan of what is it that you're going to be doing? Where are we going to be making changes? What do those changes generally look like? What is the functionality? We're not doing code reviews at that point. It's more sort of the product review. Like what functionality, what decisions do we want to be made or need to be made before we start on the implementation? And implementation details that's left up to the person writing the code. But you should get that peer reviewed as well, because other people are going to be looking at it with a different set of eyes and asking questions that you might not even thought of.
Right. So there's some general best practices for adding to a code base, and Ben and I were delineating them prior to starting this call. So I'll quickly go through a few, and then Ben, I wanted to pick your brain on one of the 4. So first things first is when you're using external code, it's really helpful to cite that code. So if you're using a Stack Overflow line for getting the max value in a list or whatever it may be, including a link to that code is really helpful because it provides context. A second point is you should always try to leave code in a better state. So don't go and document an entire code project if it doesn't have docs, but maybe help out a little bit, clean it up here and there if you have time, but also don't get stuck on improving code and getting out of scope of the initial project. One more thing is it's important to maintain a similar style to prior code. So a classic example is I used to write SQL in all perfect syntax, essentially with uppercase select, uppercase where, uppercase from, and my pinky started getting tired from hitting shift. So I started coding in lowercase. But anytime that I'm editing any of my prior code or other people's code where they use uppercase SQL syntax or the correct syntax, I always try to keep that syntax consistent. And then finally, this is something that I find absolutely fascinating and I'm learning about a lot right now, which is how complex should your code be? So there's sort of a continuous scale from writing super concise, super complex, super hard to understand code versus writing each variable out line by line, having a comment for each variable, and then that makes it super readable. So Ben, how do you strike a balance between minimizing keystrokes and writing code that's very easy to read?
I like to think of code should read like a story. And if it doesn't, if it's disjointed, so think about the structure of spoken or written language that humans use to communicate with one another. We start a sentence and it has a bunch of components to it that can express an idea to another person. And if you're listening to somebody speak about something or reading something that they've written that's conveying this idea, if you all of a sudden stop midway through and break the context lineage of that idea, it becomes very sort of dissociative when you're listening to it or reading that. It's very difficult to follow along with what is going on because that idea has been aborted prematurely. Same thing can be said if you're trying to read something in text or listen to somebody speak where they're iterating through a list of ideas in which there's not 2 or 3 or 4 concepts that are being written, but what if somebody starts listing off 100 concepts that may somewhat be related to one another, but it's sort of cognitive overload if you're trying to keep track of all of the ideas that somebody was just trying to tell you. So code is no different. And it's something that I explain to a lot of junior people who ask me questions about stuff like this. Like, they're like, well, why do you write the code the way that you do? Like, why did you choose to do this? And why didn't you split this function out into 4 different parts? Like, well, because everything is related in that. I think of functions and methods as sort of paragraphs. And I think of a class as a chapter. If you're thinking about choose your own adventure type thing, it's sort of like flipping, around in a book. But particularly with variable assignments and functions and methods, it should read as a complete unit. And when people ask about why I feel that way, or why a lot of people that write software feel that way, and why is code structured in the way that it is a lot of times in a lot of examples online, a lot of people who are new to doing this stuff think of it as, well, maybe it's more efficient for the computer to read code in this way or interpret code in this way. And then when you tell them, like, hey, actually the computer doesn't care at all. What happens with that code that's on screen, it gets converted into bytecode and then it gets processed in, through the actual compiler. It's either a just-in-time compiler like Python, or it's pre-existing, like pre-compiled code. That's how Java works and C-based languages and stuff. So the computer is just executing instruction sets of that code and then converting that into machine code that is being processed by your operating system to communicate with the kernel, to communicate with RAM and CPU and GPU and stuff like that. So the layer of abstraction that you see on screen that you're typing into an IDE, that's entirely for humans. The computer would be totally fine if you took all of the logic in your massive code base and converted it into a single line of code, which you can do. You can write a block script that has a single variable that assigns everything to it. And you can write the most complex code bases. You could rewrite them in that way. No other human, and probably yourself, would never be able to read that and understand what is going on. Just like we can't look at assembly language and intuitively, some people can, I think, but if you look at machine code and look at, the byte array instruction sets that are being submitted, you can't understand what the heck is going on there unless you devote decades of your life to understanding the syntax of that, the structure of that. So it's for people's benefit. And like we were saying before recording, that adage of code is written for every one time that code is being written, it's read 10 times. And that really resonates with the fact that code is meant to be read So you should take a little bit of care when you're writing it so that other people can read that code and understand that thought, that concept, that action, the motivation that you had in writing that. So the simpler something is, even if it looks like, oh, we don't actually need these 4 variables here. We could just do that with 1 variable. A lot of people think that the computer is going to be more efficient that way. Well, with most languages, it's going to collapse those variables into one anyway, a single object reference, because it realizes that it's just chained with reassignments. It doesn't care. It's not copying that 4 times. That variable assignment to chunk and break up the code is for human benefit, so that somebody can process that sentence and be like, oh, okay, it's calling that method with these 4 arguments. It's getting this return type from that. And now it's going to use that in the next variable assignment. It's going to call another function. And then that's how a paragraph is written. Idea 1, idea 2, idea 3. It's doing these things in order. So it tells sort of a story of processing of what's going on. Now, there are people out there that I've seen code bases where they spend way too much time and effort in trying to get that most efficient of code design of like, hey, I'm going to see how many one-liners I can put in this. And I always ask people like that, like, what are you doing? Like, why are you doing this? And I've never gotten a good answer. I've gotten answers. I've gotten people saying like, that's how code should be written. Like, says who? And I've gotten answers like, oh, well, the computer is going to process that faster. Like, no, it's not. Let's try it out. Let's do a time it. Let's validate that this is actually going to be that much more beneficial. Or somebody trying to optimize an operation that's done once and, takes the way that it's written is very readable and people can understand like what's going on. You're like, okay, how long does this take? How many times is this called in this application? You're like, okay, it takes 400 milliseconds to run. We've done a time it on this. And you can take any of that code and you can optimize it to the point where it could probably execute in less than a millisecond. It'll be on nanosecond level. Where you're like, hey, this took 40 CPU clock pulses to run. It's fast, but it's so complicated that the only people that are going to understand it are the people that wrote it and their immediate peers. So it's not a commonplace sort of way of doing that thing. And there are times to do that in code where if you're writing a function that you go in, you're like, hey, this could probably be optimized a little bit faster. And you ask yourself, how many times is this function called within the execution of this code? And you're like, oh, this is called every time we receive a REST API response from this endpoint that we're querying. And when we did the time, it takes 3 seconds to run this loop code. Well, if we rewrite this and all of a sudden the execution time drops down to 60 microseconds, how much of a benefit is that going to be? And now we're talking scalability and we're talking money. This API is getting hit 1 million times a day and you're reducing the execution time by that. That's that much less hardware that we need to run. That's real money that we're talking about. So if the implementation needs to be optimized for that use case, that's worthwhile. But if the complexity of that implementation in order to reap that economic benefit is so severe, it increases the complexity by so much that it's difficult to understand what's going on, then that's when you need to do a lot of documentation within code. Is remember, the computer doesn't care how many lines of documentation you write. Like it's ignored like text within the code base, but humans care. And sometimes, as we were saying before we started recording, what I've done for really complex implementations that we needed to do because of cost or efficiency or something, I'll write the super complex thing and I'll do inline comments, sometimes between every single line, that explain, like, hey, this is what this thing is. And sometimes I'll make references to a block code comment before that complex code. And that block code comment will have like notations on it. And that it would be, the block comment would be, hey, this is the basic way of doing this operation. Like, hey, we have these 3 collections that we're iterating through, and we have conditional logic within each one to basically break the chain if a condition is met. So here's it in like basic code formatting. And this runs like garbage, which is why we're not doing this. And I'll put notes like that. Like, this is very slow. this is the computational complexity of this or the space complexity, and this is not sufficient for this use case. The code below, here's the keys within the code here that correspond to that. So like reformat the code in such a way that you can make those links. It's like just annotations. Like, hey, see note number 7 in the code above for what we're doing here, what the equivalent is. And if you can take that, all of those notes, and run it through a peer review, and people read that, and a lot of times people like thank you in the peer review. They'll be like, hey, thanks for adding this explanation here and breaking this down, because you just saved me 2 hours of going onto the internet and searching for what the heck you were trying to do here in the code.
That makes a lot of sense.
Have you ever wished that you had a group of people that were just as passionate about writing code as you are? I know I did. I did that for most of my career. I'd go to the meetups. I'd try and create other opportunities. And it was just really hard, right? The meetups, I got some of that, but they were only like once or twice a month. And it was just really hard to find that group of people that I connected with and really wanted to, talk about code a lot, right? I mean, I love writing code. I think it's the best. And so I've decided to create this community and create it a worldwide community that we can all jump in and do it. So we're going to have 2 workshops every week. One of those or 2 of those every month are going to be Q&A calls, right? Where you can get on, you can ask me or me and another expert questions. The rest of them are going to be focused on different aspects of career or programming or things like that, right? So it'll go anywhere from like deployments and containers all the way up to managing your 401k and negotiating your benefits package. We'll cover all of it, okay? And then we're also going to have meetups every month for your particular technology area. So we have shows about JavaScript, React, Angular, Vue, and so on. We're going to have meetups for all of those things. I'm going to revive the freelancer show. We'll have one about that, right? So you can get started freelancing or continue freelancing if that's where you're at. And I'm working on finding authors who can actually do weekly video tutorials on something for 10 minutes that's related, to those technology areas so that you can stay current and keep growing. So if you're interested, go to topendevs.com/sign up, and you can get in right now for $39. When we're done, that price is going to go up to $75. And the $39 price gets you access to 2 calls per week. The full price at $150, which is going to be $75 over the next few weeks, that price is going to get you access to all of the calls and all of the tutorials and everything else that we put out from Top End Devs, along with member pricing for our remote conferences that are coming up next year. So go check it out, topendevs.com/sign up.
Cool. Well, I will summarize. So today we talked about how to forecast Santa Clauses in US malls. It's a very important topic. But no, we actually talked about how to edit and improve existing code bases and work on developing features for those code bases. Ben suggests 3 steps. The first is to look at the output and sort of think of the code base as a black box. And what you want to do is look at the inputs, look at the outputs, and understand what's going on. And then ideally document that so you have a starting place, A, for yourself, and B, to share with other people. Second, you look to understand the code base. So a really efficient way to do this is look at tests. Again, we're looking at input and outputs. We're not looking at the code yet. And then once you do understand sort of how inputs change the outputs, you can go in and read the applicable implementations of how things actually work. Then finally, when you're looking to build things out, it's important to POC and scope appropriately. If you have a lot more experience, you can often do that in your head. And if you have less experience, you can sort of iterate and build out components to estimate how long things will take you. Then 2 final tips. It's important to maintain code style for readability. And then the second is your code should read like a story. So not only should it be iterative, so the prior things should build on top of the next things, but it also should have sort of a logical flow and ideally not be interrupted. Anything else, Ben?
No, I think that covers it.
Cool. Well, until next time, it's been Michael Burke and
Ben Wilson.
And have a good day, everyone.
Take it easy. We'll see you next time.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.